I want to say first thank you for the possibility to make this short speech. And the topic would be the system approach in the development of agricultural robots. On the first slide, we wanted to show some retrospective how the mechanization in agriculture appeared. Initially, people were using domestic animals to help to process the soil because it's a hard work. And then, with appearing of machines, tractors, nothing special happened. The horse was just replaced with tractor. The producers of equipment and the producers of tractors were still split. So this solution didn't form some kind of system, some kind of synergy. So we just replaced the horse with the tractor and continued to do the same way as we were doing thousands of years. Nowadays, we move to the next step, to automatization. And there are multiple approaches in this transition. The first approach we would like to call legacy. Some solutions are trying to follow the same way as transition from domestic animals to tractors by just replacing tractor driver with autonomous navigation. So nothing special happens. Equipment manufacturers and manufacturers of the carrier, they still stay split, and there is no benefit from the new solutions, new technologies. It means that we continue the same approaches we did hundreds of years ago. And this does not give all benefit which we could get from the new technologies. Another approach called invention, where the tasks are more challenging and cannot be directly implemented by just substituting the tractor with autonomous tractor. There are some inventions are coming. Like, as example, I put here on the slide this delta manipulator for selective weed removal. Something new happens, we benefit from the technology, but still there is one major drawback. We do not think of the system solution. We do not provide a solution for the users which would cover all their needs. So this is already a step forward. It's a better approach, but still not the best. And we claim that the system approach is the best here when the requirements are being collected, analyzed, and then the solution for the agricultural robots is being formed, being invented based on the requirements. Further, I will go through the requirements which we selected and explain point by point why it is important. So mainly we formulated 5 basic requirements. It's cost efficiency. I think it doesn't need to be commented. Everybody needs to drop the production costs to make the food affordable for everyone. And then safety, also obvious. We will start to work with autonomous solutions. No damage to people or property should be done. Mobility, this means that we can apply our solutions everywhere and not be tied to some particular places and particular environments. Universality, it's also important to give a solution which will cover the needs of the farmer for all operations that he requires. And reliability. No, obviously, the more reliable the robot is, the less you spend repairing it, more it spends in the field doing some job. And now a little bit more details for each of the requirements. This we formulated as the basic things to achieve. Cost efficiency to drop in contrast to existing solutions which utilize the human labor, to drop the costs at least twice to get the to go below the margin where it becomes not efficient, not sustainable. Then initial price of the solution. If you buy some fancy robot which will use all your money resources, you will not be able to earn something to get return on investment. So the price of the solution which we should introduce into the market, into this industry, must be affordable for the farmers and be comparable with existing ones. It's an important thing. Then the fuel source. It is known that gasoline is being finished soon, and we need to switch to better utilization of energy. And one of the possible ways is going to electricity. The efficiency of the internal combustion engine is only 40%, plus minus, depends on the model, but still it's not comparable with the efficiency of electric motors. So electric motors provide us possibility to utilize the energy which we have and to save in global scale the resources of humankind. Then, of course, it must be autonomous to eliminate the labor. Nowadays, it's hard to find workers, even engineers. We cannot speak about the seasonal workers in the fields. Nobody wants to go and work from morning till night, and it's a common problem everywhere, in all countries, all continents. And it's important to eliminate the labor, or at least minimize it. Then automatization must be as maximum as possible, so again to let the system do the job without intervention of people, without supervision, and so on. Maintenance, it's obvious, you don't want to spend time and money repairing or servicing the robot which you would like it to work without headache for you. Technology is also important. Some approaches to production, to design, are more cost efficient than the others, and for providing a solution which will cover the needs of the farmers, we need to go with the cheapest technologies which are available at the moment. And of course, it's mass production. The tractors are being produced in hundreds of thousands of pieces each year, so it must be oriented and be built in the same quantities. For the safety, as soon as we were talking about electricity, it's important to specify that the voltage level should be affordable for working in wet environments. Nobody would like to repair or deal with a machine which would have 600 volts on board when you're staying in the mud, half of your feet is in wet environment, something wrong can happen and then you get a shock. So to minimize the danger to the people, to the operators, must be low voltage. 48 volts is a suitable voltage because it's quite high to get better efficiency than the 12 volt system, but still not that high to get a shock or danger to people's life. Another important point is the dependency from the software. We're working with software a lot and we know all the tricks and tricks, with kind of bugs and glitches. They cannot provide reliability. You can prove many things, following the standards and so on, but you will never prove that some microcontroller, microprocessor will work without faults, without failures. It's all kind of not fiction, but it's doubtful that software can guarantee the reliable operation of the safety systems. That's why we formulated it to be independent from the software. And of course, it must be reliable and simple to guarantee the operation time before failure. Mobility. Of course, your solution, which farmer will apply in his fields, must be transportable without headache. It's important that you don't need some special transportation trailer to bring the robot to the field, so it means the mass sizes must comply with reasonable limits. And the transportation must be simple, means loading, unloading without headache, without a lot of efforts. Just put on trailer, strap, bring to the field, unstrap and download to lose as less time as possible for delivery. Universality. It's also an important point. We believe that making a dedicated robot for each particular operation, for each particular need of a customer, it's kind of costly. The customer doesn't want to have a bunch of machines in his garage. He wants minimum amount of technique, minimum investments into the robots. So we put it as one of the important points to support all operations by one system, to not split between different manufacturers, different systems, different solutions. And of course, it must be suitable for application in multiple conditions from point of view terrain. Horizontal surfaces, inclinations, swamps, hard soil, everywhere must be applicable, to not provide, again, customization for each particular case, for each particular field, to cover the whole market, the whole agricultural segment. So, Markets means that we don't want to make a robot for some particular species or varieties. It must cover the type of agriculture, like plantations or general agriculture, without specializing in some beetroot or potatoes. It must be common to minimize the amount of models, minimize the amount of different robots, make it simple for the customer, for the market to come to this solution. Reliability is obvious. The simpler it is, the less often it breaks. So requirements to the parts, to the sensors, to the things on board, dependency of GNSS, which we know is a nice thing, but very often gives headache in special conditions like mountains, valleys, buildings, trees. Never will provide guaranteed operation. So we believe it must not be present at all. The solution must not rely on it. And here we summarized all these requirements in 20 points, which are essential for the overall shape of the ideal solution made based on the system approach. Of course, automatization to remove the hands from the agriculture, operation for all type of operations to support the whole agrocycle through the year. Reliable technologies and combining them to provide reliable base platform and instruments which will work in synergy and covered with informational systems to give feedback, to make normal supervision and storing the data about operations, about the environment where it was applied, to get knowledge about fields. Interface to bring to farmer a robot is something special because normally they are not educated, they're tractor drivers, and it's important to be too close to people, so minimum amount of efforts to start the operation, minimum amount of settings must be natural for the people. Means some applications on smartphone is possible, but not preferable for users, and we claim to make the solution with the minimum efforts for understanding how to control it. Navigation without GNSS, it's also obvious to not be dependent on external systems which might fail anytime, and we will not be able to operate your robots and stop the cycle, the production of food. Reliable sensors, which would not be dependent on the weather, means rain, fog, dust, all the things that we observe in the field, and put some limitations on the things that we can use. So mostly it's about using lidars and cameras, which will get blind in certain weather conditions and then will not provide possibility to operate at all. Monitoring of what is happening, like online streaming of data, video, to supervise, to not run around in plantations, to have control of what is happening, also important. Transportation, that I was touching before, the ideal solution must be possible to bring to the field and return back to the facility for maintenance, for recharging, without any efforts, to not get headache with this step of application, to maximize the amount of operation time. Performance on slopes, important point. Many vineyards, orchards are not located in the flat areas. In some countries it's affordable to work on horizontal surface, but in many countries these cultures, these species are grown on the hills. This means that ideal solution must provide possibility to climb those hills and do the job in the places where like regular tractors cannot do that in some rough conditions. 48 volts is our choice for electrical, for the power system, for the electrics on board, because of safety and relatively high power. Charging is important. When we start talking about the batteries, you don't want to spend days for charging the robot. You want to have it in the field immediately, so we set a margin of at least 8 hours of charging to not spend more than a shift for maintenance of the robot. Back to mechanical design. means using the electric motors, which convert energy with 90% efficiency, as was stated before. Of course, brushless motors, which are most reliable and requires minimum amount of service. Storage of tools and replacement also must be easy and fast. As soon as we are talking about universal solution, it must provide multiple operations and it cannot hold on board all the required tools. Means when you prepare the system for the operation, you will need to configure it, attach the implements, and this must go easily without headache and not waste time of the farmer or the customer. Safety system, again, we must rely only on electrics and mechanics to guarantee that it will be working reliably. It's a matter of, not matter, it is the price of humans' life and health if we do not provide a real safe system for the robot who drives autonomously. Compatibility, the tools which are available for the platform must be universal, must provide operation with the platform without any tricks, adjustments. They must form a synergy together. When you connect the carrier and the tool, they must work together and provide the result without additional pitfalls. Efficiency for the environment, we chose the electrical energy because it is the most cost-efficient source of energy. We have multiple ways to get it, and this seems to be the best solution for the nearest time until we'll discover some new source of energy. Compatibility of the fields means the solution must work on soft and hard soils, and it is essential to not damage the environment where the robot operates. So for that, the tracks seem to be the best way to implement this requirement. Reliability is again about the components. The ideal solution must work years before some failure or service is required. So it means the parts which forming this solution must be simple and reliable without necessity of adjustment, service, and other tricks. Tools must be designed in compliance with the carrier to provide the suitable dimensions, because a lot of plantations have standard for their geometry, and the most common rotation zone for the robot is 6 meters, so the tool together with the carrier must fit into certain dimensions to provide possibility and to use this space for rotation. Don't require more, don't require modification of existing infrastructure. And of course, operation time is important for the customer. It's when you try to suggest to substitute the existing solution, you would like to not decrease the performance, not decrease the amount of job that can be done. So it means at least one shift must be done before robot requires some service, some recharging, some maintenance. So this is like the minimum reasonable amount of time for operation. And we would like to stress out that with this system approach, we managed to implement this solution which fits all the requirements in our autonomous agricultural robotic system slope helper. It's a base platform with multiple tools which you configure for particular operation and cover the complete agrocycle. Basically that's it. Thank you for your attention, and I'm ready to answer your questions.
Merci Oleg.
Well, thank you very much, Oleg. We are going to ask the participants whether they have questions. And, well, you may want to raise your hand and ask questions directly. Okay, I'm going to ask the first question. Oleg, your technology. So where are you based? Where are your headquarters located? In which country?
We are located in Slovenia.
Okay. And we can see a picture, but you have a robot in the field, actually?
Yeah, we have 3 robots here on the exhibition. It's here one solution for grape picking, just behind this wall, and 2 solutions for apple picking and for mulching in the demonstration zone for orchards.
Okay. And have you got robots already in France working?
No, we didn't come to France with robots. We have established distribution agreement. So we are starting the marketing campaign and we'll provide possibility of demos and trials for the clients this year.
Et d'où la raison de votre présence.
Hence you being present here as well, so that French customers learn how to know the brand. That's why you're here, so that French customers know you.
It's not the only point to be here for the French customers. We are here to collaborate with other producers, with other specialists to discuss, make some kind of, not synergy, but let's say partnerships. We're open for collaboration. We want to show to the world that it is possible to make something that will be suiting customers in all aspects of their expectations and requirements.
Merci Oleg.
Thank you. Thank you very much for that.